All right, in this problem, we're going to graph the function y equals x squared minus 1 over x squared plus x minus 2. Now, the first thing we want to do is we want to factor and simplify if possible. Because when this factors, the numerator factors to x plus 1, x minus 1. The denominator factors to x plus 2, x minus 1. Now, this function only has one asymptote. It does not have an asymptote at -2 and 1. All right, and that's because these x minus 1's cancel, and the simplified form of our original function is x plus 1 over x plus 2. This graph only has one asymptote, and that asymptote is at -2. The vertical asymptote is at -2. To find the horizontal asymptote, we think about the limit as x goes to infinity, or if x gets really big, what does this become? Well, what I explain is, think about a million. If someone is a millionaire and you add $1, they still have $1 million. If someone's a millionaire and you give them $2 more, well, that $2 is negligible compared to $1 million. So when x gets really big, this is equivalent to just x over x, because the 1 and 2 are negligible compared to huge numbers of x. And that's the way we want to think for horizontal asymptote, because a horizontal asymptote is a horizontal line that our graph gets closer to as x gets really big, or as x gets really big in a negative sense, right? So as x gets really big, this gets closer to basically x over x, because that 1 and 2, when x is billion, a billion plus 1 is nothing, it's a billion basically. So those are negligible, and you get x over x, which is 1. So the horizontal asymptote is x equals 1. All right. Well, notice when x is -2, we got a horizontal asymptote. When x is 1, we are going to have a hole in the graph, because that denominator right there. It's still undefined, yeah? It's just we don't have an asymptote. But what is the basic graph going to look like? Well, as we come in from the left, right, as we approach -2 from the left, we basically get -2 plus 1 over -2, but we're a little less than -2, like -1.9, -1.999. When you add 2 to that, you're going to get a positive number, a small positive number. This is going to be a negative, because you're approaching -2 plus 1. That's approaching -1. And a negative over a really small positive is a really big number, but it's a negative, because a negative over a positive is a negative. But this is approaching -1, and the denominator is getting really small. And -1 over a really small number is a really big negative number. Again, negative over a positive is a negative. So it shoots up to negative. Goes to -infinity, which is down here. And then we're going to get something like this, and it's going to approach 1. Now, exactly where it crosses here and here, we could find the x-intercepts. Set this equal to 0. This is equal to 0 when x is -1, so it's actually going to cross at -1. And where does it cross the y-axis? Well, we set when y is 0, this is 0 when x is -1, and when x is 0, y is a half. So when x is 0, y is a half. So that's where it intersects, and it's going to do this. Now, what about the graph as we come in, approach -2 from the left? Well, as we come in, think about the numbers. There are two, -2.2 negative 3, negative 2.5, negative 2.1, negative 2.001, negative 2.001. Negative 2 are always a little bigger than 2, and negative 2.01 plus 2, it's going to be negative, but the denominator is going to be negative, but it's going to be getting really small. The numerator is approaching negative 2 plus 1 is a negative 1. A negative over a negative is a positive, and as the denominator gets really small, the overall value of the fraction gets really big. Big, but it's big in a positive because a positive over a positive is a positive. So as you approach here, this is going to go up, get really big, positive infinity. And then back to our horizontal asymptote, that's going to approach 1. So that's our graph. Now again here, when x is 1, there is a hole there. We aren't going to see it when we graph it on our calculator, but there is actually a hole right there because in the original problem, when x is 1, we get division by 0, but it's not an asymptote, it's just a hole. So that is the graph of that rational function.